Hello viewers and my dear students. Welcome to session 2 on isometric projection demo of my main problems. What I've done under different sessions. Under that I have chosen problem number 16 to do it using solid edge. We have already started. One session is completed. That is session 1 has covered something. Now we'll try to complete this in session 2. See here, we were at this stage earlier. Okay. Now, as you know here, this roll, you see here, this is an isometric projection of a cube over which this sphere has to be rested. Now, as you know here, I have just now told you in the first session, this, the square prism, since it is rested on a corner so that the base is elevated, all these lengths will reduce because they are all inclined to VP. As a result, they will reduce in length. That is why if it is isometric projection means it will not be 50 into 0.816. That's why this 50 into 0.816 means approximately 50 into 0.816. If you see, it will be almost 40.80. In that way, it has become isometric projection because it has been raised over a corner, so the base is raised. Please understand, the base has been raised only to see the top surface. In any isometric projection, you should always know top surface, left surface and right surface should be in a position to be viewed by the observer. That means the observer should see the top surface, left surface and right surface. Okay, that is the concept of isometric projection. That concept I have done. Now you see here, over which a sphere of diameter 50 rests on. When you imagine a sphere of diameter 50 rests here, the combined axis of cube and the sphere is an isometric line which is parallel to this. Any line which is parallel to this, parallel to any of these lines, no, either this is a top line, top square or bottom square or vertical edges, any line parallel to that will be reduced by isometric length. That means it will be multiplied by 0.816. In that way, if you keep this over this, the combined axis will be parallel to one of the vertical edges. Hence, that will also be inclined to VP, and as a result, it will be reduced to 0.816 times the original length. Okay. Now, you see here, the center of this will come from here. Actually, it is C0 to C1 should be 25, but the axis is reduced by isometric because the combined axis will be reduced. We take C0 to C1 as 25 iso. Okay, once you take 25 iso, you are getting C1. Okay, now once you get C1, now you see here what I'll do now. This I'll take the move command. Okay, move command, and hope you know the sphere won't reduce in diameter. Sphere, whatever you do, whatever you tilt in the front view, when you are observing, the observer is looking perpendicular to VP, keeping sphere, okay, since there is no corner or edge for that, it always looks like a circle of diameter 50 only in the front view. That is why spheres don't reduce in diameter, but the combined axis will reduce. Okay, that is why what I'll do now, I'll take this move, I'll select the entire thing. I'll take the move command. Move, copy is not required. Okay. Okay. Now you see here, I'll take the move command. Copy is not required. I'll select this. Okay, I'll select this and take the center as the pivot point. Okay, center as the pivot point. I'll keep it at the end of this. That means C1. Okay. Now C1 is the center of the sphere. Okay, center of the sphere. C0 is the center of the top surface of F cube. Okay. But C0 to C1 is 25 ISO. That is why what you can do is, you see here, what I'll do. I'll make this blank. Okay. Okay. Then using this text command, what I'll do, ISO 25 you draw. This will be ISO 25. ISO 25 means is 25 multiplied by 0.816. Now if you see, as I told you, better you can zoom it for better clarity and all that. Okay. Now ISO 25. Now even here, as you see here, the sphere has been rested centrally over a cube. But C0 to C1 is 25 ISO. But C1, this is actually what? Diameter, true diameter only. Because spheres don't reduce in diameter. For that, what I'll do, no, if you see this, this is, if you call this as the, this will be radius of this sphere. Radius of the sphere equal to, okay, 225. But you remember, okay, this, you write it here. This is, R of this is this, is true 25 only. Okay, true 25, the radius of the sphere is true 25, diameter is 50. In that way, this is true 25. But C0 to C1 is ISO 25. Now, anyway, we have completed this problem in this respect. Now, the actual thing, you see here, even this dimension also will do. This is examination. Okay. This you take, this you take, this you take. All will be 41, no? Because it is all 50 into 0.816. You make all of them blind. All of them blind or blank. All of them you make it blank. Okay. Then you using text command, no? What you do, ISO 50 you draw. This you draw ISO 50. Okay. This also ISO 50. Okay. Okay. In that way, you see here, this is ISO 50, ISO 50, ISO 50. Okay. But you should know C0 to C1 is actually ISO 25 because it's a combined axis. Okay. Combined axis. That is why ISO 25. With C1 as center, true 25 as radius, I draw an arc so that the diameter is 50. In that way, we are able to complete the solid, isometric projection of the two solids, one above the other. But visibility. Now visibility we always comes from the top solid, top surface first. Now it is a sphere, no? It is only this. But back edges are all invisible. That is why use split command. Use split command. You take this and at this intersection, no? You split it here. And even here, take this. At the intersection here, you split it here. Now, what you have to do is this back portion, no, keeping pressing keep pressing control key. What you do, you make it 0.13. Now, once you do this, it is in a perfect order. This is the way they expect you to do in the exam. This is isometric projection of two solids. The top solid is a sphere. The bottom solid is a cube. And you take this, first you take everything 50 and take a scale of 0.816 and finally call it as ISO 50, ISO 50, ISO 50. ISO 50 means 50 into 0.816, 50 into 0.816, 50 into 0.816. Now if you see here, there are two solids, one above the other. Common axis would have reduced because this common axis, no, this C1 is the center of this one. C0 is the center of this top surface. And if you call this bottom surface some C2, C2, C0, C1, it's a combined axis is parallel to this. Any edge parallel to the vertical edges or these top edges, they are all called isometric. They will undergo 0.816 reduction. That is why what I've done is I've taken center C0. C0 to C1, I've taken ISO 25 because common axis will reduce. Once I get C1, with C1 as center, true 25, actual 25 as the radius, draw an arc. Otherwise, you draw the sphere separately and move this with respect to center C1 here and show it as radius true 25. Okay, once you do, this will be proper. This is the isometric projection. Okay, this is called isometric projection. You do all this in the exam as I have told you. Okay, now you see here, you are learning two things at a time. Please understand, though it is a simple problem, you are learning two things at a time. That means two chapters. In your exam, you have isometric projection as well as orthographic projection. Any university will have this. Orthographic projection is also equally important, more important than the isometric projection. Okay, both you should know. Orthographic projection, what they give, no, here they have asked you to draw the isometric projection. Okay. See here, a sphere of diameter 50 rests centrally on a cube of sides 50, draw the isometric projection of combined solid. You have done it. This you have done it, this problem gets over. ISO 50, ISO 50, ISO 25. This is R equal to true 25 you have drawn. And in that way, the problem gets over and the back portion and all that you have made it light. The problem gets completed. Here you understand. Okay. Very important. Now, in the orthographic projection, in the next chapter, as I've told you in different sessions, they'll give the direction. Okay. See here, the direction leader. Either this direction they give or this direction they give. If they give this direction, the direction, if they give, whatever the direction they give, you should take it as the front to direction. Front to direction. If I give the direction here, it is the front view is this way. When you look in this direction, how it appears in the front view, top view. When you do in this front view this way, left is predominantly seen. Compulsorily you have to do the left view on right profile plane. Okay. Let us say they give this way, this as the front view. They'll give the direction of the arrow as this. Immediately what you should do, when the left view, that is when they give the direction here, this will be the front view. Front view, top view and right view on left profile plane you have to do. This is what you have to do. These things I'll tell you in the next session. That is session 3 of isometric projection demo. Okay. Thank you very much, friends. Thank you for watching. Immediately watch the session 3 also, because then only you will know the real concepts of isometric projection as well as orthographic projection. You will have a clear idea. Okay then. Thank you.